SAT Math Lesson 7 is part 1 of 3 dealing with linear functions. Now we're moving on to Heart of Algebra 3, 8, and 9 standards, right? As you can see, all of these deal with linear functions and modeling with two variables, okay? So if you can master linear functions, right, you can do really well on the SAT. There are several questions that are non-calculator and calculator based that relate to linear functions. So it is something that you must master. Okay. So first, let's go through everything you need to know about a linear function, starting with what is a linear function. Linear function is a function with two variables whose ordered pair solutions align in a straight line. If you remember from freshman year, all first semester you dealt with linear functions, which were basically the arithmetic sequences, right, that you guys worked with, okay? Now, all of these linear functions have what we call a rate of change or slope, which represents the steepness, all right, of the straight line. Now, the symbol we use for slope is m. Now, remember, if a line is going uphill from left to right, your slope is positive. If your line is going downhill, right, from left to right, it is a negative slope. Now we know rate of change or slope is the rise over the run, which ends up being the change in y over the change in x. So basically you subtract the y's, you subtract the order, or subtract the x's, but you must subtract each of them in the same order. For example, if I gave you 2 points here, say -1, 4, and 3, 6. When I go to find the slope or rate of change, I would subtract the y's. So 4 minus 6. Now, if I started with this 4 with the y's, I must start with -1 with my x's. So -1 minus 3, that would give me -2 over -4, which would simplify to 1/2. Now, it doesn't matter if you go the other way. Say I go 6 minus 4 over, now I do 3 minus -1. You have to remember when you subtract a negative, you bling bling it to get +1. 6 minus 4 would give you 2 over 4, which again reduces to 1/2. It is very important to be able to calculate the slope or rate of change with linear functions. Anytime you see the word per in a word problem, that clues you in on that being whatever that number is, like $3 per pound, right? That kind of tells you the slope or rate of change. All right. Now the y-intercept is where the point where the line crosses the y-axis, right? So if you have a graph, right, and you put a line in this graph, this point right here, the point where the line crosses the y-axis, is the y-intercept. Now, anytime a line crosses the y-axis, you have to know the x value will always be 0. So to find the y-intercept, we let x equals 0, and we solve for y. And our ordered pair will always be 0, whatever you get for y. And there can only be one y-intercept. Next is the x-intercept. This is the point where the graph crosses the x-axis. So when I look at this, right, I have my line in here. This is my x-intercept. And to find that, you know the y value on the x-axis is always 0. So we let y equal 0, and we solve for x. And when we get our ordered pair, it's always going to be whatever you get for x, comma 0. The three most common forms of a linear function that you'll work with, the most common being slope-intercept form, is y equals mx plus b, where m is your slope and b is your y-intercept. And we would write it as 0, comma b. Another one is point slope form. And in point slope form, m, again, is your slope. But what you have to understand is y1 and x1 end up being a point on the line. And that would be your x1 and y1. And remember, when we take the point and plug it in, because we're subtraction here, the signs would change. Now, in the MVP curriculum, they relate point slope form to y equals m times x minus x1 plus y1. And what they basically did is they brought this y1 over by adding it and just ended up with this equation. The last one is standard form, which is ax plus by equals c, where a, b, and c are all numbers, right? Replaced with numbers, right? They will say most likely integers, right? But they could be decimals and fractions too. Now, in this form, I'm going to tell you a shortcut here, right? This is the easiest form to find the x and y intercepts out of, but a quick way on the test to find the slope is the slope of a line in standard form will always be the opposite of what a is, meaning the number in front of x, comma, b. And that's if it's written in that form. And we'll talk about that a little bit through some examples. So the first set of problems are all ACT type problems that I felt really get you thinking about linear functions in the different parts. Part 2 will be all the non-calculator portion or problems on the SAT, and then part 3 will be all the linear function problems that are calculator based on the ACT or SAT. So first, it says, what is the slope-intercept form of 6x minus 2y minus 4 equals 0? Remember, slope-intercept form is y equals mx plus b. So what we have to do is we have to take this equation and solve for y. How do I do that? Well, to get rid of the 6x, since it's linked by subtraction and it's positive, I'm going to subtract 6x, subtract 6x. Now, I'm also going to bring that 4 over by adding 4, add 4. 6x's wipe out, and what do I have to bring down here? Negative 2y equals, 4 is eliminate, negative 6x plus 4. Now I have to get rid of the negative 2. Since it's linked to y by multiplication, I divide. And if I divide one thing by negative 2, I divide everything, not in parentheses, by negative 2. So y would equal negative 6 divided by negative 2 would be 3x. 4 divided by negative 2 would be negative 2. So right away, which function does this match up with? In slope-intercept form, y equals 3x minus 2. Okay. The next one, which of the following describes the total number of dots in the first n rows of the triangular arrangement below? Now, if you remember, MVP hit this stuff hard. Make a table, right? So in row 1, how many dots did I have? 2. So this is my row. This is my number of dots. In my second row, I had 4. In my third row, I had 6. Fourth row, I had 8. And fifth row, I had 10. Now notice, if you remember, we used to determine if it was linear or exponential from a table. And we looked at what's happening to the y values. As x goes up 1, y goes up 2. Y goes up 2. Y goes up 2. And we said back in the day that this was a common difference, right? If you had a common difference, that tells you the slope of the line is 2. So right away, you know that this pattern, the arithmetic sequence we see adding 2, tells you this is a linear function. And if I just look at the answer choices here, right? N times n will give me n squared. That would be quadratic. Not going to happen. C is n squared, not linear. It's quadratic. Here, I could get linear. I know it can't be 30 because it's not a constant type pattern. And if I look at letter B and letter E, I have to determine between these two. Just by knowing it's linear, I narrowed it down from 5 choices to 2 choices. Now, I know right away my slope-intercept form would be 2n. But that's not going to help me here. I know it might be B, but now I need to know what would the y-intercept be. Some people would probably say if I work backwards to an x value of 0, I would subtract 2, and that would give me 0 here. So my y-intercept would be 0. Other people would put it in a point-slope form. 2 times n, I'm going to subtract 1, plus my y value of 2, and when I simplify this, 2n minus 2 plus 2 would give me 2n. These eliminate to give me 0, so y equals 2n would be my function. Okay, next one. What is the y-intercept of this line? To find the y-intercept, remember, we let x equal 0. So all I'm going to do is go up to this equation. I'm going to go 6 times 0 plus 2y equals 14. That eliminates the x term and leaves me with 2y equals 14. When I divide by 2, y equals 7. Right away, letter D. Now, an overlay of an accessibility ramp of a building is placed on the standard coordinate plane so that the x-axis aligns with the horizontal, right? The line segment representing the side view of the ramp goes through the point -2, -1, right, and 16, 2. So I'm just going to put 16, 2 right about here. What is the slope of this ramp? Well, right away, if I connect the dots, the reason I make a quick sketch is I look at that line and I recognize that the slope is positive. So right away, I know F can't be an answer, G can't be an answer, H cannot be an answer. So I'm stuck between these two. Now I can go rise over run, which my rise would be to go from -1 to 2 would be 1, 2, 3. Oh. And then my run would go from -2. So my rise, let me do it in a different color. My rise would be 3. My run would be 18. So 3 over 18 simplifies to 1/6, letter J. But if you know you're just finding the slope, use the formula. Y minus y over x minus x. -1 minus 2 over -2 minus 16. That's going to give me -3 over -18. A negative divided by a negative is positive. That simplifies to 1/6, which would be letter J. Next one, what is the slope of the line? Well, right away, if I write this in standard form or I solve for y, doesn't matter, right? I'll do it 2 ways. One, I know this is ax plus by equals c. It's not equal to c because I got to subtract 18. So we would write this as 21x minus 3y equals -18. All I did was subtract 18 from both sides. Now, this is in standard form, so we said you can do a shortcut to find the slope. If this is A and this is B, we can do the opposite of A over B, which would give me -21 over -3, and that would be 7, which is letter E. If you don't know the shortcut, all you have to do is take this equation and solve for y. Subtract 21x, subtract 18, and you would get -3y equals -21x minus 18. Now, divide everything by -3. Y equals 7x plus 6. And right away, here's my slope. This is my y-intercept, which is 7. Boom. Number 6, how many ordered pairs xy of real numbers will satisfy the equation? Remember, a linear function is made up of an infinite number of ordered pairs, right? Therefore, there will be millions and millions and millions of ordered pairs that make that equation true. So right away, anytime you're asked, that will be infinitely many. So given y minus 5 equals 1 half x plus 1 is the equation of a line, at what point does it cross the x-axis? This is basically looking for the x-intercept. To find the x-intercept, we let y equal 0. So basically, if I take this equation, I replace y with 0. 0 minus 5 equals 1 half x plus 1. Now I can go ahead and solve for x. I'm going to subtract 1. I would get, now I'm going to write this a little easier to see. I would get 1 half x on this side equals negative 5 minus 1 is negative 6. Then you can either divide by 1 half, or I like to multiply by the denominator, and x would equal negative 12. So your x-intercept would be negative 12, 0, or what x coordinate would it be? Negative 12. And number 8, in the coordinate plane, what is the x-intercept of the line that has a slope of 2/3 and passes through the point negative 2, 2? There's 2 ways to do this, right? Number 1, write the equation. You're probably going to want to go point slope form to where this is x1 and this is y1, and this is your slope m. So y would equal your slope times x minus the x coordinate would be negative 2, bling bling it, make it plus 2, then your y coordinate is plus 2. Remember, point slope form is m times x minus x1 plus your y1. Now from here, to find the x-intercept, what I basically do is let x equal 0. So I would get, let y equal 0. So I would get 0 equals 2/3 times x plus 2, all plus 2. Now, is this an easy equation for everybody to kind of solve? No. What I like to do is eliminate the fractions by multiplying everything outside the parentheses by 3, which would give me 0 equals, these 3's would eliminate, and I'm going to go ahead and distribute to 2. Plus 3 times 2 is 6. Now, I basically, 0 equals 2x plus 4 plus 6 is 10. Subtract 10. 2x equals negative 10. Divide by 2, x equals negative 5, which would be letter B. That's how you would do it algebraically. But let's work a little smarter here. Anytime you're looking for any of the intercepts, just go to your y equals, right? And once you get this equation written in, right? Once I get that written in, I'm going to go y equals alpha y equals 2 over 3, open parentheses, x plus 2, close parentheses, plus 2. And when I hit graph, right, where do you see this line crossing the x-axis? At 1, 2, 3, 4, negative 5. Boom, right there. Now, up here, you could have done the same thing. All you really have to do, add 5 to both sides. Y would equal 1 half x plus 6. And right away, the only downfall with this is if you go and plug it into the calculator, it might not show up in your window, right? But just by looking at this, right, I'm going to go 1 half alpha y equals 1 over 2, arrow to the right, x, x plus, Sorry about this. X plus 6, and then arrow down, I'm going to eliminate this, right? But right away, when I look at that, right away you have two choices just by looking at the graph. You don't see it here, right? But you know the x-intercept's going to be way out here. And it looks like if this is -10, -12 would be the best approximation from the graph. So even if you forget, use the graphing calculator. Go ahead to try the practice questions and ask questions if needed.